Vegetation growing through cracks, possible moisture ingress, cracks in the concrete, and signs of the reinforcement corrosion, this rusting and breakdown of steel bars inside the concrete. These are some of the concern emerging from Bengaluru's KR Puram cable stayed bridge, and they are raising a bigger question. Is a 23-year-old bridge receiving the regular structural maintenance and monitoring it needs? The KR Puram Bridge was commissioned in 2003 and is one of Bengaluru's technically significant structures. Its 106-meter cable-stayed main span carries 4 lanes of traffic over the Krishnarajapuram railway station. Senior officials from Bengaluru East City Corporation say the bridge surface is maintained by the corporation, while the structural portion above the railway track falls under the responsibility of the railway department. But experts say the visible deterioration cannot simply be dismissed as maintenance or housekeeping issue. Chandrasekhar Sharma, General Manager, Technical Struct Rehab Private Limited, says vegetation emerging from structural or retaining concrete can point to cracks, joints, void, porous concrete, or pathways through which moisture has entered. As roots grow, they can widen these openings and retain moisture, potentially accelerating structural deterioration. And there is another concern. A senior engineer from the Greater Bengaluru Authority's Road Infrastructure Wing says the bridge was designed for the traffic and loading condition of early 2000s. Bengaluru's eastern corridor has changed dramatically since then. Traffic volumes have increased, vehicle weights have changed, and the bridge is now operating in a much more intense environment. The engineer says this is where structural health monitoring, or SHM, of bridges and flyovers becomes critical. The growth of trees and roots around structural elements, the engineer says, is an indication that such factors may not have received enough attention. The recommendation: a priority assessment of all bridges in Bengaluru, but this cannot be limited to a visual inspection. Engineers need to establish whether the bridge's present condition and current loading remain compatible with its original design. That means examining traffic volumes and composition, heavy commercial vehicle movement, repeated loading, induced vibration and congestion related effects. It also means looking at changes in road geometry, drainage and surrounding development. And for a bridge that is now 23 years old, experts say appearance alone cannot determine safety. A comprehensive structural assessment would need to examine the bridge's current load carrying capacity, the actual condition of structural concrete, the extent and rate of reinforcement corrosion, any loss of steel cross section, the severity of structural cracks, concrete strength and uniformity, carbonation and chloride penetration, the condition of bearing and expansion joints, the stay cable anchorages and associated components, possible loss of pre-stress or cable tension, deflection or abnormal deformation, the foundation, piers, abutment and retaining structures, drainage and waterproofing, and crucially, the present traffic loading compared with the assumption made with the bridge was designed. The objective, the engineer says, is to move from visible deterioration to measured engineering evidence. The assessment should be carried out by an independent and technically competent bridge or structural engineering team, supported by appropriately accredited testing facilities. Experts also point out that KR Puram is not an isolated case. Several major bridges and elevated structures across Bengaluru have now been in service for decades. At the same time, traffic volumes, vehicle weights, and environmental exposure have increased substantially. Modern repair and rehabilitation technologies can extend the service life of aging infrastructure, but only if the underlying problem is correctly diagnosed first. The proposed solution is a systematic citywide bridge assessment program that would mean identifying major aging bridges, flyovers, railway overbridges, railway underbridges, and elevated structure. They could then be classified based on age, traffic importance, structural condition, deterioration rate, and the consequences of failure. The most vulnerable structure could be prioritized for detailed assessment and rehabilitation. The larger question is whether Bengaluru will continue with complaint-driven temporary repairs or move towards a structured system of bridge management. That would mean inventory, inspection, structural analysis, diagnosis, repair rehabilitations, corrosion protection, monitoring, and periodic reassessment. For KR Puram, the warning signs are already visible. The question is whether the authorities will wait for the deterioration to become a bigger problem or act on the evidence before that happens.